Defenders think in lists, attackers think in graphs, and as long as that holds, the attackers win. Once you start pulling the threads on tax evasion and money laundering, you find it's connected to all this other stuff across the dark web. The same kinds of technologies used for finding the worst criminals in your network can also be used for finding the best customers in your network. And that's really the theme of my talk at ODSC West.
Welcome to ODSC's AIX podcast, your gateway to the latest in AI and data science. Whether you're an aspiring data scientist or a seasoned AI professional, we bring you insights from the best minds in the field, shaping the future of AI. This episode is sponsored by ODSC West, the premier AI Builders Conference, celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Seamus McGovern, the founder of ODSC, will be your host today.
Welcome to the ODSC AI Podcast. Today we're exploring how AI can be used to uncover and fight hidden financial crime networks. Our guest is Paco Nathan, a veteran in AI, data science, and now part of Senzing, where entity resolution and graph analytics power investigations into money laundering, tax evasion, and dark money flows. We'll dive into how tools like AI, RAG, graph-based AI, and open data initiatives are helping investigators follow the dark money, from shell companies and kleptocrats to the networks that fund cyber attacks, trafficking, and corruption. So stay tuned for a deep dive into AI and the hunt for hidden networks. Paco, welcome to the ODSC AI Podcast.
Thank you very kindly. I'm very glad to be here.
And Paco, I'm super excited for ODSC AI West coming up at the end of October because you're going to be a speaker there. I want to get into the topic of your talk in a little bit, but first, I'd love if you could introduce yourself to our audience, maybe tell us some key moments in your career.
Oh, wonderful. Thank you very much. And I'm so looking forward to ODSC West. I've had some wonderful experiences in the past conferences and looking forward to this year. Also, a number of my colleagues coming. I think the best way to frame it, 40 plus years ago, against all advice from my mentors, I went into a graduate program in what was called artificial intelligence. From there, I sunk further into risky waters by becoming fascinated by a topic called neural networks. Beginning in the mid-'80s, I got into neural networks, machine learning, and natural language in general. My grad advisor was Doug Lannett, well known for Psych Project, but before that for doing essentially early generative AI cases with M and Eurisco. From there, I ended up at Bell Labs. I worked for about 5 seconds for a gentleman named John Hopfield. You may have seen him as a Nobel laureate recently regarding
That's
deep learning.
right.
Unfortunately, I didn't get to stay on that project long because the Bell Labs was kind of circling the drain. So we were going through reorgs about every other week. I got pulled back into doing network engineering and whatnot. I've had a history of working in the field in machine learning and natural language. In the mid-'90s, I was with a company that had spun out of Motorola. We were doing hardware accelerators for neural networks. Back when most people were asking us, why would you bother doing hardware accelerators for this thing? I do have a background in data analytics, applied math, all that before I went into computer science. Somewhere along the lines, there were rather large, troublesome data problems. I ended up leading teams on data analytics, and eventually we began getting called data science. And along with that, I got this strange set of calls in about 2005. A colleague had moved up to Seattle and was calling me, asking about some hypothetical system, asking what could possibly be done. My answer was, well, I didn't think this sort of thing existed, but here's how we might approach it. It turned out to be AWS. I got pulled in as a technical co-founder for a startup the same month that AWS launched. I went to the VCs and I said, there's a new thing called cloud. I think we can really conserve our capital by using cloud. That was True Ventures. They were like, we're 100% behind it. So we got to be one of the early startups doing 100% cloud architecture back in 2006. One of the projects we were working on had a lot of troubles coordinating NLP machine learning workflows. So we heard of this new software that had just been released December of that year. It was called Hadoop. We jumped on board, started using Hadoop in the cloud, found out there were some problems. We brought in a guy who wrote the book, The Definitive Guide to Hadoop. We brought him in. He pushed a pull request so they could run efficiently on EC2. And we became one of the largest Hadoop instances. I got involved as a case study for AWS. And that led me to a guest lecture at Berkeley. They were doing some analysis of cloud. So I gave a guest lecture, and the students in the audience some months later would found a little company called Databricks. So eventually I found my way in there, and I was on exec staff at Databricks back when the company all fit in one room. It wasn't for long, but we could still feed everybody with a few pizzas. I had fantastic experiences traveling the world, teaching thousands of people how to use Spark. I've landed at a company over the past year and a half, a company called Senzing. You may not have heard the name before, but most people use it in some form or fashion under the covers. They probably don't know about it. But for instance, the majority of voter registration in the US goes through Senzing Library for entity resolution. A lot of looking for fraud patterns or criminal networks, tax evasion, et cetera. So basically, we talk about hunting bad guys, referring back to some of the origins of the company in Vegas. The same kinds of technologies used for finding the worst criminals in your network can also be used for finding the best customers in your network. And that's really the theme of my talk at ODSC West.
Yeah, it's a great segue. Criminals and customers, searching for both.
Yeah, exactly.
Very unique approach.
I was going to add that it's kind of a postmodern condition, but it is certainly in finance. You see the case where sometimes it's hard to tell the difference between the worst criminals and your best customers. Sometimes they look much the same.
Indeed. Senzing's origin story is quite fascinating. Started with casinos and Jeff Jonas and what he was doing there. And then there's an association with MIT card counters. So if you can tell us a little bit more about Senzing, especially the lessons from those early days that still apply in today's massive scale investigations, tax evasion, money laundering. If you can talk a little about Senzing's early work.
Certainly. So we mentioned about Jeff Jonas, our CEO. The three co-founders, they've been together for 30 years. And in the core engineering team, most of the core engineering team have been working together for at least 20, 25 years. So
Wow.
This team has been through a lot of evolutions of this kind of technology, but also just the evolving landscape, certainly the threat landscape, whether you're talking about cyber threat or money laundering or human trafficking or whatever. Yeah, so Jeff Jonas was a programmer at the Mirage Casino before they opened, helping build out infrastructure. And one thing led to another. It was something that at the time they were calling non-obvious relationship awareness. If you're looking at how organized crime will move in on a casino, they've got their network, they're doing their things to access a lot of money or whatever they're trying to accomplish. They're probably trying to pay off some people, so there's insider threat as well. It's the kind of thing where you can look at the chain of beneficial ownership for shell companies, see who's manipulating what, but you can also look at who might be neighbors. There's a funny story. One of the early demos they did, they were considering an individual who was on the no-fly list for the casinos. If he was allowed back in a casino, they could possibly lose their gambling license and be shut down. During the demo, they got an alert that the casino's DBA was having a meeting with this guy at lunch. The people were like, we have to take care of something. We'll be right back.
You got an alert during the live demo. Wow.
Yeah, that's an example of this kind of non-obvious relationship. You have to look for those because the bad stuff is happening behind the scenes. Even with banks, you still have a lot of problems of insider threat. A lot of the very large laundromats that we talk about, the large industrial scale money laundering activities, largely out of Russia, are occurring in finance. These are professional operations. They have armies of attorneys, accountants, financial counselors. They hire people. They pay off people who might be working somewhere in a bank. They're quite complex. And interestingly, they're networks, right? They're always graphs. So if you can start to find out what's going on, number one, by pulling the threads, putting the pieces together with entity resolution, and then number two, start to look at some of the graph analytics and perhaps some AI applications downstream, leveraging the graph data, then you can start to make sense out of these kinds of threats. And I guess I'd close that with saying John Lambert at Microsoft Threat Intelligence has a great quote. He wishes he had a nickel for every time people repeat it, but defenders think in lists, attackers think in graphs. And as long as that holds, the attackers win.
Yeah, that's a great quote. And I think you mentioned this in your talk abstract as well. In terms of looking at graph networks, I think you're going to talk about is the Azerbaijani Laundromat.
That's correct.
Saga, as well as of course, a lot of us in Europe know about the Danske bank case. They were both staggering operations. So can you explain a bit about both those operations? I think you already explained the Laundromat one a little bit, but Danske bank is another great as well. Billions of dollars involved. Can you walk us through how those operations typically work from a networking and graph perspective?
During the talk, we'll show some forensic accounting and graph analytics and visualization. I know of people who were involved with taking the documents from the whistleblower in the Danske bank case and then doing some forensic accounting. At the core of this, they have a lot of shell companies. The shell companies may be registered in the UK or someplace where it's easy to set up a company, but then they're moving money around internationally and trying to shuffle it in ways that make detection of what's going on very difficult. So if you have a bank where they're ignoring the problem or there's somebody's paid off, you get money coming in from sketchy sources. In the case of Azerbaijan, there were kickbacks from Russian weapons purchases that went under the table to leading families in Azerbaijan. They took that money offshore. They had also embezzled a lot of money out of the Azerbaijani state, and they moved that through about 400 plus shell companies, shuffled it around, and did tricks like bogus invoices. So they say, oh, yeah, we need to do this large money transfer to pay off this invoice. The invoice would be used 3 or 4 times over the next few months in different cases at different companies. It was really bogus accounting. By shuffling this across a network, you end up with thousands of transactions. And it's inhumanly possible for a bank analyst to look at thousands of transactions and piece it all back together into a network flow. Now, computing, this is something we can do. It's not that difficult. But for bank analysts looking at one money transfer on the wire, the scope of the problem is much bigger. And then ultimately, they'll take, and they're called deals. The shuffling part is called layering in banking. And then they take the money out through other companies. That's called a deal. And then they'll use that money to buy condos, pay for luxury items, or pay off EU officials, things like that. And there were 4 UK companies who were essentially the deals part of it that drained all the money, even though they were not operating in the UK. They were just registered there.
Yeah, that's fascinating, Paco. Really, really insightful. And I guess an obvious or non-obvious question is, how did you and your team learn to model and detect the tradecraft behind these kinds of laundering and fraud operations?
That's fascinating. I will also reference people who are much better at this. There is a gentleman named Graham Barrow. Ray Blake and Graham Barrow have a podcast series, analysis series called Dark Money Files. And Graham Barrow is actually one of the people who was brought in to analyze the legal implications of Danske Bank by the law firm investigating it in Denmark. Oddly enough, Graham Barrow almost became the 5th member of the band Queen. There was a point in his life where he chose
Really?
whether to be a professional musician or keep his bank job. A really fascinating guy. He had been investigating a company that had shown up in the UK public register called Companies House, where all corporations have to be registered and there's public data about them. And Graham Barrow had been investigating this firm called, if I remember correctly, Lantana Trade LLC. Bizarre company. What was going on with it? It was just a lot of outliers. When people started digging in, they found out it was being owned and operated by the Putin family out of Russia, which is when a lot of bells and whistles went off. I think that was actually the event that precipitated the whistleblower inside of Danske Bank. Because once he realized that he was essentially shilling for
Yeah.
Putin, I think he was like, I'm out of here.
Wowzer.
These patterns of tradecraft are very important from a technology perspective. Working with graph technologies and AI, we look at things like network motifs and essentially graph patterns where we can apply geometry, topology, et cetera, to try to analyze patterns and see where they show up elsewhere and actually get a lot of purchase out of that. Because the basic patterns, even though they're always evolving, a lot of the basic patterns get repeated over and over. So in the case of what we're talking about here, there would be a pattern like rapid movement of funds where you have multiple companies, all with different bank accounts. One of the red flags is that they're treating each other as both suppliers and customers, which usually doesn't happen. And they're also moving in money rapidly and then draining the account rapidly, which most companies, most people don't do. Usually you try to keep a balance. There are poker tells like that. But then there's also patterns where they'll move to one company, bleed off a few percent of the capital, move to another company, bleed off a few percent, on in a ring until they can get back to the origin of essentially laundered money. Maybe they've lost 10%, but if you can invest it the right way, you might make it, for instance, buying a condo in London, you might make your money back quickly. So a lot of these patterns are really of interest. And frankly, the agencies and ministries across the world who look at this, the banks who are looking at this, are getting to the point of being able to actually have some means of exchanging abstracted patterns. Like almost you could think of like threat advisories in cyber, where you've got some kind of vulnerability, some kind of exploit, and that can get published as a CVE. So there's movement toward being able to express these patterns and then broadcast them so that everybody can watch them.
Yeah, that's very interesting and so fascinating. You mentioned at the start, entity resolution has been so fundamental to many different disciplines, data science, NLP. I still think it's very much an unsolved problem, even in the age of generative AI.
Very much
If
so.
you can speak to why entity resolution is so foundational in fraud detection.
Certainly. Thank you. Entity resolution, a good way to describe the problem, it's actually a very large problem. A good way to describe it is if you have multiple data sets and you want to find a footprint for, say, a person or an organization across these different data sets, don't assume that you have foreign keys and it's just a matter of doing a SQL query, because that won't work. I can guarantee if you're in banking, if you're in defense and intelligence doing this kind of work, you are buying from data providers. There's also open data sets from open OSINT, essentially. So you're bringing in data from a lot of places. Do not assume that you can do a foreign key. You have to find out better ways of merging and tracking the people and organizations. You really have to look at it in a probabilistic sense, because depending on the risk tolerance for the organization and the use case, you may not have enough evidence to say person A is to be merged with person B, but we have collected enough evidence so far to say, yeah, it's likely. And therefore, if you're doing an investigation and person A pops up, one of your hot leads is going to be person B. So essentially, we're creating a probabilistic graph behind the scenes, collecting evidence to support, do we merge or disambiguate? A merge might be that you have Robert Smith at 123 Main Street with a certain phone number, and then Bob Smith shows up in a different data set at 123 Main with the same phone number. You can say, okay, well, we think these are the same person. But then subsequently, you would get a Robert Smith Jr. and a Robert Smith Sr. with different birth dates at the same address, sharing the same phone number. Somebody, a father and son live in the same household. It's important because if you're looking at a thing like voter registration, there are people who would say, oh, well, clearly this is voter fraud. No, actually, these are two different people. So you need to be able to merge and disambiguate based on the evidence. And you're always getting new records. The challenge is, can you make those merge and disambiguation decision points within milliseconds of having a new record arrive, even though there might be billions of records being considered? And can you keep an audit trail of all the evidence that went into the decision? Because ultimately, when you're talking about the identity of people and organizations, if you get that wrong, then it means somebody's going to be denied a loan or blocked from being able to vote, or their passport will come up invalid, or the police are deployed to the wrong address to kick down the door. A lot of bad things happen if identity gets wrong. If something goes bad, people and organizations will go to court because of harms that have happened. So if you're involved in these kind of use cases, you need to be able to show proof of evidence, a chain of evidence for all decisions that are made. And so that's why this area is something you don't want to just go out and do a bunch of fuzzy string matching and say that you're done, because it's doubtful that will hold up in court. And likewise, if you just throw all the data into an LLM and then deploy a SWAT team and kick down a door, and your justification for doing so is, well, GPT told us to, guarantee judges will not like that very much in court. And to your second point, though, about where does this fit in with AI? When we're doing entity resolution, then essentially we're creating a kind of overlay. If we want to talk about a semantic layer or some sort of semantic overlay, think about, you have a lot of different data records providing areas of evidence. Some may have an address, others may have a phone number or a tax ID. There's both elements, features of evidence that can be used to be stitched together. So you create this kind of overlay over the top that says, here's what we're detecting as a stable entity. Here's the best names. We've assessed data quality across all the records, and we think that these are the likely most recent addresses, et cetera. And here's the records they point to. And as you're doing that kind of analysis, creating entity resolution, the result is essentially nodes and edges and properties which feed very naturally into building a graph. And for investigations, that's increasingly a lot more use of knowledge graphs like this. From an NLP perspective, going a little old school here, if you talk about ontology engineering, the elements that go into any kind of semantic layer, any kind of ontology work, would be that you have a taxonomy. For the programmers out there, a taxonomy is another way of saying a hierarchy of classes, just like you would have in Java or Python. You also have thesaurus, which is essentially your instantiated objects and all their aliases. Or a thesaurus you might think of, here's a word, here's all its synonyms for a given case, a given domain context. You typically have a vocabulary, which is, to a programmer, you could say, these are all the public classes for the libraries you've imported. This is what you could possibly use. But the point is to use these elements of taxonomy, thesaurus, and vocabulary to tie down your definitions within a domain in ways that everybody involved can agree. And if you're working in public sector, oftentimes there are regulatory compliance reasons for what definitions must be satisfied. Entity resolution is interesting because it can take different data sets and generate a domain-specific thesaurus. If you are working in something like RAG or agentic workflows, having that thesaurus to constrain within a domain, what do you actually mean by these terms? Who actually is Robert Smith at 10123 Main? Now you can make much more accurate and accountable decisions if agents are taking actions. What are they building on? What are you feeding into the LLM, and what kind of constraints or guardrails are you putting on the results? The source comes in really handy. I'll illustrate this in terms of what we would call entity linking. When we're building and working with graphs or graph RAG, we talk about entity resolution, named entity recognition, and then entity linking to merge between them. Essentially, it's a way of saying, how do you work with structured data, unstructured data, and then blend them together in an intelligent way that's very domain specific. That's the key to working with LLMs, keeping the definitions consistent within the domain as a way of getting really better quality results out of them.
Yeah, I think, Paco, that's so fascinating because entity recognition has had a long history. And in addition to that, as you said, I've done work in it myself for financial applications and other ones as well. But those false negatives, as you mentioned, were so important. They had real ramifications. And the techniques we were using at the time, like rules-based programming languages, using systems like JRules based on Java. Then we went to more probabilistic fuzzy matching techniques. And then over the years at ODSC, we've had talks around machine learning based techniques and, of course, neural networks and clustering algorithms. But the graph-based networks you're talking about are very interesting. And of course, graph RAG is now a thing. Yeah, I would love if you can talk a little bit more about graph RAG because that's another hot topic we're going to be discussing at ODSC West.
Certainly, I'll be showing some open source projects that we have as tutorials, but frankly, they can be used as production libraries. Graph RAG is interesting. I wrote an article about this last year with my friend Mike Lukides at O'Reilly. When you look at the different graph projects, the word graph means something different. We've counted up to 8 different definitions of the word graph. So depending on who's talking, there's a lot of different flavors of this. Just unpacking that is sort of step one. The thing about it is, if you go back to grade school where you're taking a sentence and you're diagramming the sentence according to its grammar, if you can think of that kind of parse tree of a sentence, using NLP tooling, advanced NLP tooling like Spacey is fantastic. You can produce a parse tree like that, where every word, we know what part of speech it is. We can infer that with very high accuracy, thanks to language models. We can also infer things like, here's a noun phrase, and then for that noun phrase we've detected, we can apply some sort of label to it using classifiers. And that's what you mentioned, named entity recognition. That's what that does. So if we step back and we say, I've got 1 million documents, they're PDF documents, they're very salient to this human trafficking ring we're trying to track down. I want to ask questions based on new things that are coming in. I want to ask questions through a graph RAG system out of all these millions of documents. But, I want to tie down for any given question. I want to get the pieces of the documents that are actually most relevant. We can use recommender systems technology, vector stores, embedding models. We can do that kind of vector search, which is the RAG part, to say out of 1 million documents, here's the top 20 chunks of text that are actually closest to the question that's being asked, and then throw that into an LLM and get a summary. But you can go a step further and take all those chunks of text and parse them. And from those grade school diagrams of grammar, essentially think of those as trees, parse trees. And so if I had the verb gerund running, I could find that its root is run. If I had the word children, I could find that its root is child. And I have parts of speech for them, and I have their position and their groupings as far as like noun phrases, things like that. Those parse trees have a lot of information. And if you take them all together, you can essentially build up what's called a lexical graph. So there's a really noisy graph directly derived from the text. There's a class of algorithms called text graphs where you can do essentially page rank on that level of graph, and from it be able to surface what are the main topics out of the documents that are being referenced. Because in human language, we're always self-referential. This is how stand-up comics work, of course, but this is how any author works. So you know that there's this kind of graphies to human text or human-generated text. If we can create graphs out of the text and then surface out what are the main key points, now we've got some entities and relations among them. If we can start putting labels based on the domain that we're in, for instance, I'm going to show a case where we took some research out of Harvard that had to do with dementia, risk of Alzheimer's, and the implications of a 40-year study of eating processed red meat versus other alternatives. And so there are a number of hospitals in the Boston area who were involved. There were a number of researchers. There were these papers produced. And then there were a lot of articles downstream reporting about the research outcomes. And so in the example, we'll take and build up a very small taxonomy of the semantics, like what's the definition of a hospital? What's a doctor? What is medical research? Just enough that we kind of have a toehold so we can start to parse. And we feed those in when we're doing the entity recognition. When we're parsing the text, we say, be on the lookout for the name of a hospital or a name of a researcher, et cetera. And then we can start to construct a graph on that side out of the documents that are published, the research papers, business directories, et cetera. But we can also have some structured data that describes researchers, maybe off of ORCID or Scopus. We can talk about business directories of hospitals in the Boston area. And we can run entity resolution to pull those records together and create, again, the source part of this. And when you put all that together, you end up with a pretty interesting ontology that essentially is the graph guiding your graph rag. So now when I have a question for the LLM, I actually send it in two directions. I send it in the direction of look for all the text chunks that are pretty close to this based on the embedding models, but then send it out to the graph. What are the entities in the graph that are close to this question? Then let's look at their neighbors, their relationships. Once we've built up that little subgraph, we can run some graph algorithms like PageRank running centrality and find out what's really the gist of what this article or this question is getting at. Because you may ask a question about dementia and not even use the word Alzheimer's, but yet in this context, that is more closer to what you're asking about. Alzheimer's is one of the forms of dementia. You may ask a question about processed red meat. Salami is a kind of processed red meat. Hamburger is not. The health benefits are very different between the two. So by traversing the graph, finding out what's really interesting, you can go back and filter the different chunks of text to get them even closer. One of the problems with RAG is recall. You may ask a question and there may be very good answers, but they're just not anywhere close. The embedding model will miss them. The graph can pick them up though with a fairly efficient way. And so what I'll show is essentially driving this whole thing with a very small knowledge graph to start it out, running through different documents to pull in additional information, having the entity resolution as kind of backbone, but then at runtime using different LLMs to end up with the graph rag results. And it's fun because you can use Ollama, run this stuff on your laptop. It's not that expensive. You get very high quality answers.
Yeah, so much to unpack there because you've touched upon so many great points. But just looking at embeddings themselves in vector databases, you can compress vast semantic information into these vectors, but they can be lossy. That's one of the things we struggle with our graph databases. They're good at looking for entities, but not rare entities.
Yeah, exactly.
Lose some of those relationships, not good for edge cases. You mentioned unstructured text. We struggle because we do a lot of research from papers coming down. A lot of unstructured text can be difficult to deal with. So you think GraphRag solves some of those problems, compound some of those problems?
It can really help out. I was mentioning research out of Harvard in dementia. You look at the authors, some from China, some Korean, and you look at how, for instance, how are nicknames handled in Korean versus how they're handled in Arabic or Russian. You've got all these cultural norms. And unless you make the investment linguistically and culturally, it's very hard to resolve that. So you end up missing a lot of the linkage that you should have, especially once you get out into the unstructured text. That's one of the things that we do at Senzing a whole lot. We've invested over the years. We now have 80 different globalizations. I studied Arabic a long time ago, but if I were to take a name out of Arabic, depending on the dialect, I could translate that into English or Italian or whatever. It'd probably go 5 different ways, and they're all legitimate. And if a person's made a pilgrimage, they'll have a prefix al-Hajj. If their parent is famous, they'll have a suffix bin Amir. If there's a nickname, it'll go a particular way depending on the culture. The same individual could have all these different variations, and trying to pick that up when you're going across texts that have mix and match in different languages, it's an utter nightmare. But yet, when you're doing KYC and due diligence at a bank and you're looking at the correspondent bank's reference data, that is exactly what you have to do. Or you'll miss it, which is what Danske Bank tried to argue in court, because they were getting all this money coming from Russia and it was being transliterated through Estonian. I don't think the people who were making the decisions even read the source language.
And so getting back to your talk around the dark web, what were some of the telltale graph patterns or behaviors that often indicate money laundering from the other sources that you know?
Oh yeah, the money laundering side of it is really interesting. It's kind of a shame because when you look at popular media, there's a Netflix movie which has tried to illustrate some of this. They illustrate the outcomes downstream, which are horrific, but the actual money laundering themselves, they never talk about. So the money laundering is very strange because usually there'll be some kind of dirty accounting, like bogus invoices and sending money transfers to places, basically paying yourself and claiming it's an expense. So then you've got both money laundering and tax evasion. But it can get really bizarre. Like, for instance, if somebody hijacks a truck full of mobile phones, and maybe the list price is like 200 euros per phone, you can kind of deal with somebody in a different part of the world and say, I'm going to sell you these wholesale price, 600 euros. But then you have a deal through a consulting arrangement where you get a kickback for like half of that. So what I'm trying to describe is there are mechanisms where they can actually do these flows of money by bogus trades on materials, and they can adjust it to make the money flow in any of those directions, while at the same time avoiding sanctions happens, whether you're talking about stolen goods, watches on Amazon Marketplace that look like they should cost hundreds of dollars, but they only cost $1, but then they have exorbitant service fees. This also happens in the bonds market, where you have junk bonds that essentially evade sanctions for currency exchange. So there's a lot of mechanisms where if you're smart in finance, you can adjust where the money is going. And if there's a few bogus deals under the table, you can make it very profitable for all parties. These are the kind of things that I see.
Wow. Yeah. Just reading the abstract for your talk at West, I would encourage our listeners to check out your talk abstract, even if they're not attending. You mentioned a figure of $3 trillion passed through shell companies worldwide.
Yeah, and that's just the B2B. Those are the money transfers we're talking about for B2B. You know, there's lots more, and we're not even talking about cryptocurrencies. In that instance alone, it's believed that there are upwards of 200 billion euros of money laundering through that one branch of a bank in Estonia, mostly involving 4,000 non-resident accounts, mostly in Russia, in a period of just a few years. 200 billion, which was, there were times when the transfers through that one branch were larger than the GDP of Estonia, the host country.
It's unbelievable. When I used to live in London, I was out with a friend one night who's in fraud investigations. I was looking at a new building in Hyde Park, just went up in a couple of years, and it was mostly dark. Yeah. And he said, do you want to see the dark money? That's the building. They would just buy them. They'd not live in them. But again, your abstract mentions references people who hunt the bad guys, like investigative journalists, people who work in open source intelligence, regulators, government agencies, law enforcement, financial crime investigators. And what has stopped them from just crawling the dark web? Well, a lot of it's closed off to the community, right? It's by invitation.
Difficult, yeah.
Yeah, it's very difficult. In our email exchange, setting up this podcast, you had mentioned a couple of open source tools, which are actually quite popular now, DSPy and BAML. And so if you want to talk about how AI tooling can help in this fight and agentic workflows in general.
Certainly, I'm a big fan of both of those. And I think the teams behind both DSPy and BAML, they're really excellent. I've been using DSPy especially a lot lately. The gist there's Apache Spark from Databricks, my old home. And then there's another project, which is called MLflow, which is another open source project, very popular. But that's the workhorse. These days with generative AI, MLflow is so compelling because you're just collecting log telemetry across all stages, and then you can try to aggregate or have a hypothesis. The new Gen AI features in MLflow are awesome. Just saw a talk on that. There's another project called DSPy for people who are familiar with AutoML. And I believe I taught a class at ODSC in AutoML. We take the ideas of AutoML once we've been running a machine learning project with MLflow. Once we've been running it for a while, we can go and collect, is it good or bad? Here's the cases we were worried about. We can use machine learning to tune the hyperparameters. So the idea is if you have a generative AI workflow where you can do your context engineering, you can imply what should be in the prompt without writing these really long prompts. Instead, can you just imply what should happen? And think of running a SQL query. When you run a SQL query, you do not go out and say, okay, here's all the B trees I have to hit and These are all the operations that need to be conducted. Instead, you just say, at the end of the query, this is the condition that I expect. This is the result set based off of these joins. And then under the hood, your SQL engine is generating a plan and then optimizing it. So the same thing with DSPy. You say, okay, here's going to be my different inputs into the LLM, and this is the kind of output, and this is the type that I'm expecting on these different components. And these are some conditions that must be met to constrain it. And then it generates the prompt. But you can also instrument with MLflow and collect evaluations. After a while, if you've collected these, now you can go back and optimize how those prompts are being generated. So you're leveraging this long backlog of effective tooling and using AutoML to enhance your context engineering, how these prompts are getting generated specifically for your use case. And you see some great benefits over time. But the long story short is you're using more software engineering approaches, programmatic approaches to accessing how you integrate with LLMs. It results in much less code, smaller prompts, the ability to do better evaluations and better, say, unit test coverage, and just all around much better for software development lifecycle.
Yeah, that's very cool, Paco. I'll include links to DSPy, BAML, and even MLflow in our show notes. It's very interesting. You mentioned grounding downstream AI in graph content. Can you talk a little bit more about how that helps improve AI accuracy and even accountability?
Definitely. And this gets back to the notion of a thesaurus. When you're writing, you want to make sure within a context, you're using the right definition. So, if I use the word cat, I'm maybe talking about a house cat, or maybe I'm talking about a mountain lion. In my neighborhood, we actually have mountain lions come down the hill. Or maybe you're talking about a piece of construction equipment or a Broadway musical. Cat could mean a lot of different things. And if you don't have the context, things can get confused. And this is a problem in LLMs that's been measured. They're much better operating within a specific domain. And once you cross multiple domains and try to leverage LLMs to make sense of the semantics across domain, that's where language models tend to get confused. And frankly, for good reason, because if you look at what language models are supposed to be doing, they are based on generalization. So that actually makes some sense. To be much more effective with your AI apps downstream, you really want to tighten down the domain context. And frankly, it's good advice. We're hearing this throughout industry in other areas, like when we talk about data mesh, we also talk about having data products within a domain context and being able to have the people who produce out of that context have their semantics sent over to whoever is consuming the data product. So how can we really tie down the context? Tying down the context is great if you happen to be doing context engineering. That's kind of the game. Right. How can we get more control over what the definitions are? This is where we see leveraging semantics, leveraging techniques like entity resolution, building up graphs that give you the ability to navigate it. I will show doing a semantic random walk. That's a fancy name for something we were talking about before, where the graph can navigate to get you better answers. But they can also help as far as explainability. Like I took these steps. If you want to know why, we can go back into the graph and explain, how do we derive that inference? There's something symbolic. And so this is where we talk. I just got out of a conference called Neurosymbolic AI down in Santa Cruz. Really fascinating. But basically, how can we marry the best of both worlds of symbolic inference, something like graphs or probabilistic languages like Datalog? How can we marry that with the immense power that we have out of LLMs and embedding models, and for that matter, reinforcement learning, genetic algorithms, and all the rest? How can we put these tools together and have hybrid AI solutions that use the best of both worlds for any particular component?
Yeah, interesting. I'm sure neurosymbolic AI is an alternative architecture to LLMs. I'm sure there's a lot of potential there for looking at fraud detection and whatnot. I'm not sure if you wanted to comment on that.
Yeah, you're right on the money there. LLMs can do so much, but really constraining that context is the game. And there are times when you really want to leverage the other side to do that.
Yeah, and just to wrap up here, Paco, let's talk a little bit about open source, because we just mentioned open source intelligence and these models where you're trying to crawl data from the dark web, which is very hard because those marketplaces, those forums, for the most part, they're encrypted, invite only, and they've got these very quick takedown protocols if they detect a threat and they bring up somewhere else. So that's why open source initiatives are so important in this space. As you mentioned, you're abstracted for investigative journalism and efforts to make corrupt transactions more transparent. Can you talk a little bit about the open source initiatives in this space?
Certainly. I think this is one of the brightest spots. There's really a community for this. A friend of mine, Friedrich Lindenberg, is CTO at Open Sanctions in Berlin. And they put together from, I believe, 250 different sources or so, always adding more. They have this data set that shows, who are the people who've been sanctioned? Who are the people who are disallowed from being a corporate officer because they were convicted of bribery and money laundering? Who are the people who are, there's a term called politically exposed persons. In every jurisdiction, the laws are a little bit different, but there are formal rules that say that if you're the spouse of an ambassador in some country, your application for a bank loan is going to be handled differently because the probability that you might be getting bribed or somebody would attempt to bribe you is much higher. Can you go across the world and look and see who are the known bad operators? What are the companies associated with? What are the risks we're talking about? I mean, is this a person who was convicted years ago, or is this somebody under current investigation? So investigative journalism is a lot at the core of this, and a lot of open source. And bringing this together, open sanctions really tells you about risks. There's another one called open ownership. There are other ones in category 2, like open corporates. Can we look at the linkage, the glue between all these different people and entities? We'll talk about beneficial ownership, which is a big trend these days across the world. Essentially, who owns or is a director of a company, who may be orchestrating things from afar. And so there's great data available for both these categories. And it's very natural that since it is linked data, once you put it together, it's very natural to run it in a graph. There's also another organization called Glyph, which came out of the 2009 financial crisis, where companies engaged in certain types of financial transactions must have a formal legal identifier. It's called an LEI. And that is law across the world now. So when you start pulling in a lot of these open data sets, you can really get a lot of optics on who are the players. If you are doing entity resolution on your customer database and maybe data from Dow Jones or Orbitz or SAR, you start pulling it all together and then you notice, oh, that customer I'm doing KYC, they actually show up in the open sanctions, and here's the risk. Bells and whistles should go off. I want to shout out to all the people who put so much effort into these projects of open data, how much of a service they're doing worldwide.
Definitely. It's interesting because I know it doesn't matter if you're a small business in the US or a large business. If you've got multiple bank accounts, at least once a year, they'll reach out to you and ask if you're doing business with certain individuals, certain companies and whatnot. Many companies don't have the software to deal with that. So I've had to help do that and name entity recognition. I'm sure it's a problem a lot of our listeners are familiar with. And it's about the open source data sets you say, because training or testing the AI tools for doing this kind of detection must be very interesting. I would assume, apart from having these open transaction data sets, you want to build these simulators for modeling money laundering behaviors. Is that something that's currently ongoing in the community?
Certainly, it goes back to what we were talking about with patterns and like the motifs, the patterns of fraud, tradecraft. I have a really interesting AI application that can detect these kind of patterns. I need some data to test it out and evaluate it. Open sanctions, open ownership, life, et cetera. I mentioned there's a few others. They really talk about who are the people in the organizations and the risks involved. What they don't have is actual examples of fraudulent transactions. That's something that's typically highly confidential. There's another category. There's something called a SAR, a suspicious activity report, which banks are required to file if certain conditions get flagged. The SARs get circulated amongst FIUs across the world and intelligence agencies. That kind of data is almost impossible to get. But we mentioned about the Azerbaijani Laundromat and Danske Bank with their Estonia branch. There were 17,000 records leaked by the whistleblower. Once he found out that the Putin family was involved, he sent out PDFs for about 17,000 transactions. And I mentioned Friedrich Lindenberg and Grant Barrow. There are a couple of people who did a lot of the early analysis of this. We do have some legit large-scale examples, unless you happen to be, let's say a large database vendor who has got a customer at every large bank. You're not going to have access to the SARs or the transaction data. What you can do is work with synthetic data. For instance, we've built a simulator using patterns of fraud tradecraft to use the legit leaked data as statistical patterns. From there, we can use simulations and generate synthetic data that can go test out the applications later on. So if you have an AI app that's catching these patterns, now you've got a way that you can do evaluations on it. And that whole cycle of like ML flow and DSPy and the AutoML, you can bring all those tools to bear. IBM has another simulator for more credit card transactions, but there are these simulator packages popping up. I'll be showing one of those. I'll be talking about that for people to use.
Fantastic, Paco. And for people interested in working in this space, I do hope they have a chance to catch your talk at ODSC West. How can people follow your work, Paco?
Most certainly, we'll have a link. I post a lot on LinkedIn, and there's a Entity Resolved Knowledge Graph LinkedIn group, which it's gotten a fair amount of traffic. There's also the Graph Data Science group that I moderate. I'll post my other links under sessionize.com. I also have a podcast that I do called Graph Power Hour. And every month we bring in notables in this field.
Great name.
It's a little cartoony sometimes. Thank you. I have an episode coming up tomorrow with my friend Christoph Linson from GraphAware. We're trying to elevate a lot of this because in the work that I do, a lot of the people I work with may talk publicly, but not with a name. They don't have last names.
Okay,
legally. We can't disclose that. But I can show open source and open data to illustrate what's going on. That's what we're doing with our tutorials and podcasts and whatnot, is just try to elevate what's going on. If people want to get involved, we can point you to certification in combating human trafficking. Frankly, money laundering is used for large-scale badness like human trafficking, illegal weapons transfer, even illegal fishing. Once you start pulling the threads on tax evasion and money laundering, you find it's connected to all this other stuff across the dark web. So if you want to get involved, we have resources we can point you toward. It just kind of happenstance, but several speakers at ODSC West we have a community, actually not little anymore, but it's called Graph Geeks.
That's right.
Please come join us.
Yeah, I know some great speakers there from Graph Geeks. Yeah, Pac, I think what you're doing is so important. I can only say thanks for coming to speak at ODSC West about this, because a lot of people are interested in discovering more about the space, because we know that there's pros and cons of AI. So we have to have good guys working on the side of AI, making sure that it's used for good and to counteract the use for bad. Thank you again, Paco. This has been an absolute insightful conversation, such a masterclass on this topic. Really appreciate it. And we'll be seeing you in 6 short weeks at ODSC West.
Thank you kindly, Seamus. I really appreciate the opportunity and really enjoyed the conversation with you here today. Really looking forward to ODSC West.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. This episode is sponsored by ODSC AI West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at ODSC AI and use the code PODCAST for an exclusive 10% discount. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.